There is a number that no one talks about at dinner, not in the news, not in school, not in any of the conversations you had today about traffic or weather or what to make for dinner, but physicists know it, astronomers know it, and once you understand what it means, it will sit with you quietly, persistently, for the rest of your life. The number is this: the Milky Way is approximately 13 billion years old. Our sun is 4.5 billion years old. That means there are stars in this galaxy that formed 8 billion years before ours. Civilizations that could have emerged if the physics allows it, and we have every reason to believe it does, while the rock that became Earth was not yet assembled. 8 billion years is not a number your mind was built to hold. So try this instead. If a civilization arose on a planet orbiting one of those ancient stars, and it developed technology at the same rate we have, just the same rate, nothing faster, it would today be 8 billion years more advanced than we are. 8 billion, we have had electricity for roughly 150 years. Now, look at the sky tonight. Not a single confirmed signal, not a single artifact, not a single structure, not a whisper from anything anywhere that did not originate on this planet. A galaxy that has had 8 billion extra years to fill itself with voices, and it is silent. That silence is not a small mystery, it is not a gap in our data that better telescopes will close. It is the loudest thing the universe has ever said to us, and what it may be saying, what the mathematics quietly, relentlessly suggests, is something so unsettling that most people, when they first encounter it, instinctively look for the error in the reasoning. There is no error. Step back to 1960. A young radio astronomer named Frank Drake aimed a 25-meter dish antenna at two nearby stars, Tau Ceti and Epsilon Eridani. The project had a quiet, almost humble name, Project Ozma. It ran for 4 months. It found nothing. But Drake was not building a telescope. He was building a question and learning how to ask it properly. In 1961, he gathered 11 scientists at the National Radio Astronomy Observatory in Green Bank, West Virginia. It was a small group. The kind of meeting that goes unannounced, held in a building with no particular grandeur, attended by people who had brought their lunch. Drake had written the equation on the blackboard before anyone arrived. When the scientists filtered in and looked at it, something quietly extraordinary happened. They realized they could not agree on the numbers, not by a small margin, by millions. One scientist estimated the fraction of planets where life arises as close to 1, nearly inevitable given the right conditions. Another placed it so low it was effectively 0. The same equation, the same variables, the same 11 people in the same room, and the answers spanned the entire range between a universe teeming with civilizations and a universe containing only us. Drake understood what this meant. The equation was not a calculation, it was a mirror. It reflected back whatever assumptions you carried into the room, and the only way to replace assumption with knowledge was to look, to actually listen, to point instruments at the sky and wait. Among those present was a young astronomer who had grown up reading science fiction in Brooklyn, and then discovered with some relief that the real universe was stranger than any of it. He had spent years advocating for the scientific legitimacy of this search, the search for life beyond Earth. For him it was not a peripheral curiosity, it was the question that gave all the others their weight. Drake wrote an equation on the blackboard. You have probably seen it. You may not have fully understood what it says. The Drake equation is not a formula in the strict sense. It is a framework for organized ignorance, a way of breaking down what we do not know into categories, so we can at least understand the shape of the uncertainty. It asks, how many technologically advanced civilizations exist in the Milky Way right now, capable of reaching across interstellar distances to communicate? And it answers by multiplying a chain of probabilities, the rate at which stars are born. The fraction with planets, the fraction of those planets where life could arise, the fraction where it actually does, the fraction where intelligence develops, the fraction that builds technology. And finally the one that made the room go quiet, the average length of time such a civilization transmits before it goes silent. Even with the most conservative estimates at each step, even with the numbers set low by skeptics, the equation produces a result greater than 1. It suggests we should not be alone. It suggests the galaxy should be filled with voices. So where are they? In 1950, the physicist Enrico Fermi sat at lunch with colleagues at Los Alamos. The conversation drifted to extraterrestrial civilizations. Fermi listened, considered the numbers, and then asked something so direct it has echoed through science ever since. The universe is 13.8 billion years old. The Milky Way contains somewhere between 200 and 400 billion stars. Many of those stars are billions of years older than our sun. If even a tiny fraction of them have planets capable of supporting life, and if life given enough time occasionally produces intelligence, then by now, by any reasonable calculation, the galaxy should have been explored and settled many times over. Civilizations with even modest technological development, given enough time, would have spread, would have built, would have been impossible to miss, and yet, nothing, no signals we can confirm. No artifacts in our solar system, no megastructures visible to our telescopes, no response to the transmissions we ourselves have sent. This is known as the Fermi Paradox. But calling it a paradox almost makes it sound like a puzzle, a clever riddle with a satisfying solution waiting somewhere nearby. It is something harder than that. The silence has a possible explanation. There is a name for it. And I want you to hold the name at arm's length for a moment before I hand it to you, because the concept, when you understand it fully, reframes everything that follows. What if the reason the sky is quiet is not that civilizations never arise? What if it is that they almost never survive? In the 6 decades since Project Ozma, the search has expanded far beyond anything Drake imagined in that small conference room in West Virginia. The SETI Institute, founded in 1984, has used some of the most sensitive radio receivers ever built to scan billions of frequencies across enormous swaths of sky. The Allen Telescope Array, the Parkes Observatory in Australia, the FAST Telescope in China, the largest single-dish radio telescope ever constructed, with a collecting area the size of 30 football fields. And since 2015, a program called Breakthrough Listen, backed by a $100 million commitment, has extended the search further and deeper than any effort before it. Behind much of this work is a woman named Jill Tarter. She spent the better part of 4 decades as the primary scientific force behind SETI research, not as an administrator, but as a working astronomer, sitting at consoles, analyzing data, designing search strategies. She is the person the character Ellie Arroway in Carl Sagan's novel Contact was built around. When Sagan wanted to show what it looked like to dedicate a life to this question, he looked at Tarter. She once described the scale of the search this way: imagine the ocean, now take a single glass of water from it, examine every molecule in that glass, find nothing. That is approximately how much of the radio spectrum, across how much of the sky, humanity has managed to search so far. The ocean remains. What the honest accounting of all this listening has found is nothing conclusive. There have been anomalies, signals that briefly raised attention, then resolved into satellite interference or instrument malfunction. The WOW signal remains, still unexplained, still sitting in the data from 1977, but without repetition, it cannot be confirmed. What the search has primarily produced is a very careful map of the silence. And here is what that map tells us. The silence is not a matter of insufficient listening. It is not a gap in our technology. We have now listened carefully enough, and broadly enough, that certain explanations for the quiet have been ruled out. If a civilization within several hundred light years of Earth were broadcasting with the power output of our own television transmissions, we would have detected it by now. The sky is not quiet because we lack the ears to hear it. The sky is quiet. The Hele in 1998, a philosopher named Robin Hanson gave formal shape to something scientists had been gesturing at for decades. He called it the Great Filter. The reasoning is this: somewhere in the chain between the formation of a rocky planet and the emergence of a civilization capable of expanding across a galaxy, there is at least one step that almost nothing survives: a bottleneck. A barrier so severe that it reduces the probability of passing through to something close to zero. The emptiness of the observable universe, that vast measurable quiet, requires explanation. The Great Filter is the most parsimonious one, but the concept immediately divides into 2 possibilities, and the difference between them is not merely philosophical. The first possibility, the filter is behind us. One of the earlier steps in the chain, the origin of life from chemistry, the development of the complex cells needed for multicellular organisms, the evolution of genuine intelligence, is so improbable that it almost never happens. Life itself, or life of our complexity, is extraordinarily rare. The galaxy is not full of voices because the competition to produce a voice is almost impossibly steep. We arrived at the finish line of a race where almost everyone fell before the halfway mark. This interpretation is humbling. It makes this world, this ordinary rocky planet orbiting an unremarkable star at the edge of a typical galaxy, something close to unique. Not special in the way of divine favor, but special in the way of extreme statistical rarity. The second possibility is harder to sit with. The filter is ahead of us. Life may not be particularly rare. Intelligence may develop on many worlds. Civilizations may arise with some regularity across the galaxy, but something happens to them, something happens to all of them, or nearly all, after they reach the level of technological capability we have now reached, something that ends their transmissions, ends them. Every civilization that ever existed in this galaxy faced what we are now facing, and almost none passed through. The sky is quiet not because the universe is empty, but because it is a graveyard. Barmeinfout. Carl Sagan believed that extraterrestrial intelligence almost certainly existed. He believed the numbers in the Drake equation, even conservatively estimated, pointed toward a populated galaxy. He spent years building public and scientific support for the search. He co-founded organizations dedicated to it. He wrote a novel, Contact, in which the first message from another civilization is, characteristically, not a threat or a salvation but an invitation: come and see. But Sagan was not naive about what the silence implied. He held both things simultaneously: the hope that we were not alone, and the sober recognition that the Fermi Paradox was real data.
He understood that if civilizations routinely destroyed themselves before achieving the ability to communicate across interstellar distances, the universe would look exactly as it does, nearly empty of deliberate signals, quiet in the specific frequencies we know intelligence would use. In his final years he returned repeatedly to a phrase, technological adolescence. He meant a phase, perhaps a universal phase in the development of any civilization, in which a species has learned to extract and concentrate enormous energy, but has not yet built the wisdom or the institutions to manage that energy without catastrophe. A phase in which the capability to cause irreversible harm runs ahead of the capacity to prevent it. He watched his own century build weapons capable of ending complex life on Earth. He contributed to the scientific assessment of nuclear winter. The paper that showed a large-scale nuclear exchange would not merely destroy cities, but collapse the agricultural systems that sustained billions of people. He understood that a civilization could design its own extinction faster than it could design its own governance. He did not say this was inevitable. He was precise about that. He believed that civilizations could pass through the adolescence and survive, but survival was not guaranteed. It had to be chosen. It had to be chosen by each generation that arrived at the threshold. Frank Drake lived long enough to watch the search he began in 1960 expand into something he could not have imagined in that small conference room. He died in September 2022, at the age of 92, having spent more than 6 decades listening. He never received a confirmed answer. In one of his final interviews, he was asked whether a lifetime of silence had made him doubt. He said it had not. He said that the absence of a signal told us something important about where to look next, not about whether to look. He said the question was not whether other civilizations exist, but whether we were asking it correctly. He spent his entire adult life refining a question. That too is a way of answering it. The silence of the sky, through this lens, is not a mystery about other worlds. It is a message about ours. If we are rare, if the filter lies behind us, if the emergence of complex technological life happens once or twice in a galaxy the size of the Milky Way, then what takes place on this planet in this era carries a weight that cannot be overstated. The Milky Way contains stars that formed billions of years before our sun. If intelligence develops wherever the conditions allow, there should be civilizations so far ahead of us that the comparison collapses language. And yet we find no trace of them, no engineering on a galactic scale, no unmistakable signal, no trace. This could mean we are among the first. The galaxy may be experiencing something like a dawn of intelligence, and we may be among the earliest to wake. That is not a comforting thought in any simple sense. It means that what happens here, in this brief window, in this particular arrangement of matter on this particular world, may be in a meaningful sense, the closest thing to unique that we know exists. And if the filter is ahead of us, if the quiet is the accumulated silence of civilizations that arrived exactly where we are and did not pass through, then what we are living through right now is not ordinary history, it is the threshold. We do not know which reading is true. We may not know for a very long time, but the shape of the question is not ambiguous. Either we are precious because we are rare, or we are at risk because almost everyone who reached this point is gone. Either way, the silence is speaking. Return now to that August night in Ohio. A telescope sweeps a patch of sky. A signal arrives at a frequency no natural source is known to produce. 72 seconds. And then nothing. A scientist writes one word in the margin of a printout. Wow, consider what it took to hear that signal, even briefly. Generations of physicists working out the mathematics of electromagnetic radiation. Engineers designing receivers, sensitive enough to hear a whisper from across light years. Astronomers with the patience to listen to silence for years, knowing that a single anomaly might be lost if attention wandered. The universe did not make this easy. It never has. What strikes me, what has always struck me, looking at this question from every angle it offers, is not the absence of confirmed contact. It is that we looked. It is that we built the instruments to look. It is that we developed, on this small world, in this brief window of cosmic time, the capacity to recognize the significance of the silence. We are, as far as any evidence suggests, the only arrangement of matter in the observable universe currently asking this question. That is not a small thing. You are made of atoms forged in stars that exploded before this planet existed. You are the temporary configuration of elements that spent billions of years cycling through stellar furnaces, drifting through interstellar space, condensing into a world, organizing themselves over billions of years of chemistry and biology, until they arrived at this, a mind capable of looking at the night sky and wondering whether anything else is there. The silence does not diminish that. It intensifies it. If we are the only ones listening or among the first, then the responsibility of what we do with this moment is not a burden placed on us by some authority. It is the simple consequence of the situation we are in. The sky is quiet. It has been quiet for 47 years since the one signal we cannot explain. It was quiet for the billions of years before Frank Drake first pointed his dish at Tau Ceti. And somewhere in that silence, there is either the comfort of rarity or the warning of precedent. What we know, what the physics tells us, what the biology tells us, what the history of this planet tells us, is that we are brief. Cosmically, absurdly brief. But in that briefness, we became aware. We looked at the sky. We listened. The universe has been waiting for a very long time for something capable of understanding what the quiet means. You are that something. The question now is, what you do with the understanding. Carl Sagan spent the last years of his life insisting that the most dangerous moment in the history of any civilization is the one it is now in, powerful enough to destroy itself, wise enough to know it, and still undecided about which to choose. He died in December 1996. The WOW signal remains unexplained. The sky remains quiet. The search continues.